Hello, everyone. Welcome to the webinar. We're just giving a few minutes to those that are lagging a bit behind, but yeah, we will start shortly. Can you confirm that you see my screen while we give 3 more minutes to the other attendees? You see it okay? Great. Thank you, Nikos, for confirming. Great. So we'll give a couple more minutes and we'll sure. Okay, we're giving 1 more minute where almost everyone that registered is here, but let us wait a few seconds. All right, so let's start with an overview presentation. Well, thank you everyone for being here.
Now it works.
Okay, great, Paris. All right, so let's start. Just a disclaimer: the meeting will be recorded. It's being transcribed, and by default, all the participants that are not speakers, your camera and your microphone is turned off by default. However, you may interact with the chat just like Erwin did. And for the speakers who are not given the floor, I would please ask you to mute yourselves. Okay, so let me make a quick start on this. So we welcome to this public validation workshop of the Smart Living EPC web platform. I'm Pablo Carnero. I work for REVAT, Federation of European Heating, Ventilation, and Air Conditioning Associations. And and the speakers that will accompany me today in this workshop are Mr. Paris Fokaidis, Associate Professor from Frederick University Sustainable Energy Research Group. He's the scientific coordinator of the Smart Living EPC project, which is the framework of the project that is hosting us today. Then we have Nikos Katsaros, Research Associate from the Center. Sorry, there's a typo there. It's from CERF, but yeah, he'll be explaining that in a minute. And then we have Leandro and Aitziber from Deusto University. So very quickly, the flow of today's webinar is the introduction of the project by Paris Fokaidis, then the live demonstration of the Smart Living EPC web platform by Nikos, and then we'll have a feedback session hosted by our colleagues from UDEUST. So just a quick disclaimer before I give the floor to Paris. The intention of today is to have an interactive validation. So you may ask any question through the Q&A of the Teams meeting, but please know that throughout the presentation, feedback forms dedicated for specific sections of the tool will be shared via the chat, and you're more than welcome to provide your feedback through those forms so we can gather and structure the responses and the reactions to this Smart Living EPC web platform in this public validation. All right, so this was it from my side in terms of presentation, and I would like to give the floor to Paris Fokaidis. So please, Paris, you are free to share your screen and start with the presentation.
Sure. So, it's a pleasure to be in this workshop with you to present the main outcomes of our project. My role for today is just to give an introduction on Smart Living EPC project, to describe the project in a nutshell, the objectives of the project, the vision behind this project, and then to give the floor to our very good friends and colleagues from CERT to present the tools that have been developed in this project. Now, this project was funded with the Cluster 5 Destination 4 goals of 21. And actually, the kickoff date of the project was the 1st of July 22. The duration of the project is 36 months. We are currently actually not in 33, we are in month 35. And we have a very, let's say, rich and impressive consortium consisting of 17 entities from 12 countries, including technology providers such as CERT or IES, academic partners like Taltech, AIR or Frederick Research Center, industrial partners like R2M or White or Demo, and of course with associations like RIVA on board. We also had colleagues from standardization world, esteemed universities like the USTO, pilot managers like Goyener, and Demo. So it was a consortium that covered all the needs of this project. Now, the main idea of the project is demonstrated in the following two slides. We have approached the certification aspect of buildings in two levels. The first one is the asset-based level. That is the assessment of buildings based on the assets that are installed in the buildings. We call this in the proposal the static building information. That is information that does not change over time. And under this cluster of information, we have included the Smart Readiness Indicator, the non-energy use, the asset energy assessment, the life cycle assessment, and the technical audits. So we delivered the methodology and information for all these four fields, which were integrated into the asset assessment of the building. And we also had the operational assessment of the building, the so-called dynamic assessment of the building, which included aspects like operational energy rating, life cycle costing based on the actual performance of the building, indoor air quality, and of course, other operational aspects. So this was the main approach of our work, the fact that we have seen that that the different assessments for the sustainability of building may either be asset assessments or operational assessments. So into this framework, we integrated different meanings, like, for example, the certification on a building level as well as on a district level. So another major approach of the project was that we investigated how we can deliver solutions for assessing the energy performance of a unit, of a building unit, as well as of a set of buildings, some building units together within a building block or within an urban district. So the idea was that through this background, an information exchange model was developed, which fed the tools that were developed by CERT and by the other technical partners, and which will be demonstrated in the next presentation. Of course, some very nice interfaces were delivered out of the project, which are user-friendly. And the idea of the project was aligned with definitions like digital building logbooks or digital twins. So the operational assessment was based on measured data. To this end, these good practices related to the digitalization of information related to physical assets were well integrated in the project, and of course, some added value services were also delivered. This will be demonstrated later by Nikos in his presentation. Now, as a project, we had some key objectives, the main of which are presented in the slide. So we wanted to deliver a next generation energy performance certificate that would deliver reliable, replicable, and cost-effective energy performance methodology. In our work, we wanted to integrate other assessments of the building, such as, for example, the smartness assessment or the sustainability assessment within the rationale of assessing the performance, the sustainability performance of a building. We also integrated aspects that allowed for an expansion of our methodology to a neighborhood scale. And of course, we integrated the definition of the operational assessment, which is something very important. Our project, together with our sister project Credible, are also promoting practices for the operational energy assessment of buildings through standardization activities. At the same time, we wanted to deliver a solution that would be considered as Industry 4.0 compliant and integratable into DBLs, into digital building logbooks, which is what we envision as the future for a sustainable digitized built environment. One of the main aspects of our approach, which will also be demonstrated later, was that we proposed for a new rating scheme, the SmartLivingEPC scheme, which resulted from merging and from considering the different ratings from different schemes. And our idea is that we should move from the energy performance assessment to the sustainability performance assessment, in the sense that we should not rate the building only on its energy performance, but also through considering other aspects, such as, for example, the sustainability performance, the smartness performance, the performance of the building technical systems. So the main vision that we aspired and that we were able to deliver from this project was a new rating scheme that would integrate all possible assessments that are related to the sustainability of buildings. This is our work plan, and this is how we managed our work all these 3 years. We had an initial work package in which we set the definitions and we collected the data for piloting and for the architecture of our tool. We then had 2 work packages which focused on the asset and the operational rating of the building. We also had another two work packages which focused on the development of the tools in which our theoretical work was integrated. And we also had a work package for demonstration and capacity building. Today's workshop is under work package 6. And as all projects, we had our work packages which are related to communication and dissemination of results, as well as to project management. Now, the envisioned impact of the project, of course, is for a more energy efficient building stock with given targets in all aspects of sustainability, that is societal, technological, and for integration purposes. Our solution is compatible and it moves towards smart cities and smart buildings. We also respect the goals for a more environmental friendly system for building assessment. To this end, we had affected the lower environmental impact of the built environment. And of course, we aim to enhance the quality and the living conditions of European citizens with the solutions that we propose and with the enhanced assessment that results from our work. We supported standardization with our work, and this will be evident also in the near future with the expected standard for the operational rating, which was also supported by SmartLivingEPC. And of course, our rationale is based on the life cycle approach in the sense that whatever we do is always in compliance with circularity and life cycle principles. Now, this was a short introduction for the SmartLivingEPC project, and I believe we can move on with our next presentation.
Thank you very much, Paris, for the keeping with the time and being so concise and but at the same time detailed. In case again, if there's any questions, feel free to post them in the Q&A of the webinar. Nikos, the floor is yours.
Thank you, Pablo. Thank you, Paris. Well, thank you everyone for joining this final workshop for the validation of the SmartLivingEPC project. In short, I'm Nikos Katsaros. I work as a research associate in Center for Research and Technology Hellas, although CRS also sounds sounds good, Pablo. And well, I will present to you the SmartLivingEPC platform, which essentially is the software outcome, the main software outcome of the project, which actually aggregates all the research that took place within the project into a software product that tries to present the results that were studied within this period of 3 years almost. So let me share my screen, and I hope everyone can see it. Right. Okay. So just to remind you that, as Pablo mentioned in the beginning, the presentation process will be a little bit interactive. So at certain points, I will just stop and give floor to our colleague partners from the USTO in order to inform you about the actual presentations, and for you to fill in the feedback forms that we have prepared for you. This is a process that we need in order to gather your feedback. That will also be used in order to fill in any missing details until the end of the project to actually enhance the whole experience of the SmartLivingEPC platform. So without further ado, let's jump in. So the platform itself does not differ from any other platform, let's say, in terms of user management, as you know. Anyone can register within the platform using their credentials and selecting a role from the drop-down menu here. So we have defined 3 roles within the Smart Living EPC project, and they range from the lower access level to the higher access level. So the first one is the building tenant, which essentially is a residential user who actually gets the results of their buildings shared with them in order to have an overview of their buildings' efficiency and sustainability throughout its life. So they don't have they don't have access to any of the tools to actually change values, but they are only able to view results. The second role and the most crucial one is the EPC assessor. So EPC assessors are users that are able to upload new buildings, actually perform different assessments, and change the results that are visualized within the platform. We have also kept a role called authority as an overviewing, let's say, role. Essentially, it's a building tenant with access to many buildings, and it's reserved for authorities who might need to have access to a greater set of the actual building stock in order to gain more insights that will later on provide ground for other standardization activities, let's say. So considering that we have registered within the platform, as we have done already with an account called Smart Living EPC Assessor, we can log in and move to the next page. So the first page that anyone should visit is the profile page. This contains all the useful information, and it will also contain some authentication measures like the verification of your email in order to be able to use the platform, and also a unique API key here, which I will mention later, and the user identifier, which is also useful for interacting with other users. And also you can, for example, change your password from this page. The next one is the BIM file area, or BIM management page, as we call it. Here, all the files that are being uploaded to the platform are listed in an alphabetical order, and we have access to them continuously from this page as long as they remain uploaded here. From here also we can upload new files to the platform. This is what we're going to do at this point. So we're going to upload a new file. We have prepared a test file for you in order to be able to view the process from the start to the beginning, of course, simplified to the extent possible. So as long as we upload the platform, the file to the platform, and as soon as it follows some basic requirements regarding the characteristics within the IFC, the attributes that we have in them, the file is uploaded normally just as it did right now. So now we can see the actual building entry here. It's the one that we just uploaded. Now, there are a number of distinct, let's say, features here and also a certain process that should be followed in order for the file to be more easily processable within the platform. Well, the first one, of course, is to assign a unique name to the building itself in order for us to be able to distinguish it from other buildings within the platform. So we'll just go ahead and name it webinar test building. And so now we have a more clear view of where the building actually is. The next one is, and this is quite important, to also change the location of the building. Typically within IFC files, designers tend to add location, but it's never that accurate. So here, as you can see, the building has been placed right within the Thessaloniki Center in Greece. And we're going to change that. So by searching the address or a certain point of interest, for example, we can place the building somewhere else. So this building actually corresponds to a small building that is supposed to be within CERT, within the complex of Center for Research and Technology Hellas. So this is what I'm going to do. I'm going to just search here, and I'm going to get some results here. So selecting the one of them, the building actually is placed within the CERT complex that we have right here. So I'm going to change the coordinates a little bit because it will be coinciding with the smart house, yeah, but not that much. Let's just say just a little bit. And right, so now it's placed more or less, let's say, within the complex itself. So we change the coordinates, and the building now has been placed to the right location. Now, another option here is to actually share the BIM file with other users. So right now you can see the file is shared with no one. This is useful because we are able to collaborate on the same file as different EPC assessors, or as an assessor, we are able to share the BIM file that we just, the whole building entry that we just created with building users in order for them to be able to view the actual results of the assessments. So we have prepared for this reason a dedicated account called Webinar Tenant. So this is an account that will also be shared with you at the end of the workshop in a dedicated email, and we will leave this account open for 1 week, for example. So you will be able to also enter with the credentials that we will provide in order to be able to view the results that we got today as a building tenant. So this is where the identifier of the user comes, because we need to know this identifier here in order to be able to share the building that we just created with other users. So this is what we're going to do right now. So we log in again back as an EPC assessor, go to the building, and we just share it with the unique ID that we have. So the building is shared, as you can see, and now you can also see that we shared it with the corresponding user right here. There is also an option to transfer the BIM ownership in case we are assessors and we don't want to have the building as owners, we want to transfer for it, for example, to another assessor or to a building tenant. And there's also the option to manually edit the BIM file. This is also quite important because it's quite usual for BIM files to contain errors within them. So this is the digitalization of the. Just let me close these pop-ups here. Okay. So this is where all the information from the IFC file is digitized and is available for us to edit in real time. So we are able to basically change anything within the IFC file, starting from the building characteristics and going to different thermal zones that we have, to spaces, for example, and things like that. So an important thing here is that we can actually change the parameters of systems, like, for example, renewable energy sources or thermal systems as heat pumps, as we have here. This is quite important because this is how the results from energy audits that are being carried out to the building throughout its lifetime can actually be entered here. So considering that an energy audit might result into different parameters for the production efficiency of a heat pump, we can actually come here and edit the related value correspondingly. The same thing can be done, of course, for any of the elements that we have. For example, considering that we perform some changes in the building, we can come here to the basic structural elements and change, for example, their thermal transmittance of a wall, something like that. Now, as soon as we have finished performing all the changes here, we are able to first assign a unique ID to the building itself. This is very specific to the project, and this ID is unique and used to actually match the incoming information streams from IoT devices from the building with the building digital instance that we have here. For the sake of easiness at this point, we will just proceed without assigning the token, and we will get the measurements in another way. Finally, the tool that's accessible from here is the BIM digital logbook, which is let's say an aggregator of all the information and changes that have been applied to the building from its first upload to the platform until, of course, its deletion from it. So right now you can see that it contains a few changes. So this is the source file that we uploaded, and it just says that we renamed the file, we changed its location accordingly, so we can see details from here where its location was set exactly, and that we granted access to a new user. So every change that we perform will be actually listed here within the lifetime of the file of the building within our platform. Now, moving away from here, and as soon as we finished setting up the file, we can go to the so-called device management page that we have right here. So this page contains all the devices, meters or sensors that have been designed and have been integrated within the IFC file, and they are uploaded here, probably with not so correct data, depending, of course, on the design of the platform itself. So right now we are able to actually edit the devices here, but also we are able to perform to actually add some devices ourselves in order to connect them to actual devices that are displayed within the building. So this is what I'm going to do right now. So I will just for the sake of the presentation, I will add a few devices here. So the first one that we are going to add is a temperature humidity sensor that is used for the assessments. So let me add here. So it's a device that actually measures temperature and humidity in one of the spaces of the building. So this is H here. So we select where this device is installed. Let's say that it's installed within space 2 of the building itself, and we assign a unique name. Let's call it test sensor, test temperature humidity sensor. And we also assign a unique ID, which is used to identify the information that comes from the building, the real-time data that actually contain this unique ID with the device, the static counterpart that we have here. So we have prepared some IDs that actually match the information streams that we have. So I'm going to add them like this. We are also going to add a few more devices. So the second one is a CO2 sensor that is installed within space 1, let's say, and well, its name will be test CO2 sensor, and I will also add a public ID here for the sensor itself. Good. And finally, we're also going to study, of course, the energy efficiency of the building. So we need the actual energy measurements from the building itself. So we're going to add a few energy meters that are supposed to be connected in real time and provide us data from the building itself. So now we are going to add an energy meter that actually measures the energy consumption of the entire building. And let's say that this building here, we need to actually select the energy services that this energy consumption actually serves. Now, let's say that this building has a heat pump, of course, and some appliances, some lighting, and also an electric heater. So we're going to select all the services as the energy meter is installed at the very beginning, let's say, of our electrical installation. So right now we just select where this where this meter is installed and to which spaces does the energy consumption actually refers to. So we select the entire building, so all its spaces, and this is more or less it. We also assign, we also call it a test meter. So this will be the first one, and we assign a unique ID as well. So right here and here. Great. And for presenting, we're also going to add another energy meter. Let's say that we also measure the consumption of the heat pump that we have within the building. We measure it separately. So we are able here to just select heating and cooling as energy services that this energy meter covers. And then we're going to install it at the same place. And the heating and cooling of the heat pumps actually refers to all the spaces of the building. And we just select, also we select one of the systems that this information actually comes from. So we call it just as test meter 1. And we assign a unique ID as well. And this is it. So more or less now we have added a few devices and we are ready for the next step in the energy assessment. Just to let you know here that there is no need to actually have information streams coming to the platform at real time. We can also do it manually from this point here. So we can basically upload a CSV file containing some basic information using measurements from the building collected in another way, for example. In this way, we are also going to get the information that we need, the actual data from the building up to the platform. Or, of course, we are able to download the measurements that we have in this building into a CSV format, since we also act as a real-time data aggregator of the building information from IoT devices. And at this point, I will also stop for a little in order for you to be able to fill in a few questions, to answer a few questions about the process that has been presented to you so far. So I kindly ask Leandro or whoever is from the USTO to take the floor and share with you the first part of the survey.
Hi. Good afternoon to everyone. Please, Pablo, do you send the link for the questionnaire? For this first questionnaire? For all
Section 1, right? So the first out of the 3 that we have?
The first, please, yes. First of all, to explain that all the answers are totally anonymous. And thank you very much for your participation and for sharing with us your expert opinion. You are in the role of EPC assessor in this case to improve the tool. This first section has three parts. The first is related with with the digital building logbooks integration to EPC assessment with 10 questions with 5 levels from strongly disagree to strongly agree. And the second part is around the technical system audits integration to EPC assessment with 4 questions. In this case, with 5 levels, of course, from not at all to a very great extent. And the last part in this first section is related with human comfort integration into EPC assessment with 4 questions again, with different measures from 5 steps, from a standard element to not available or extremely difficult to very easy, depending of the question. Now we have 5 minutes to 2 minutes, sorry, to answer to these questions. Thank you very much for your collaboration.
So in case, you see the overview of the questions there, sharing by Nikos in the screen. And yeah, if you could please take a couple of minutes to go through these questions on your own laptop, and remember that the questionnaire, as indicated by our colleagues from Udeusto, will be anonymous. So this is just you're again thanked to provide this honest feedback that will help us in this last stretch of the project to improve one of the key exploitable results of it. So yeah, let's give a couple minutes, and if someone has any doubt and would like a clarification of any of the questions, feel free to also post it in the Q&A of this meeting. We'll give Nikos until 1:45 if you want, and then we can proceed. We have half an hour ahead, and yeah, let's try to keep it within time.
Okay.
Perhaps we need 1 minute more.
All right, Nikos, if you want, we can continue with the rest of the demonstration. And thank you all for the contributions, and we'll be asking at a later stage for another round of feedback.
Great.
Thank you.
Sí.
Great. So this actually concludes the the first part that regards the setup of the building of the building unit at this point, because as we will see in a later stage, we also have a different type of setup for building complexes. And we are practically ready to actually start the assessments that we have integrated within the platform. So the first group corresponds to the asset rating assessment, or as we call it, as designed, which actually relies on only on the design characteristics of the building without any actual information regarding its real-time state. While the operation rating actually uses data collected from the building during its operation, or as operated, as we call it, in order to perform the different types of assessments. So without further ado, we just start with the asset rating. So the first group of indicators that we studied within the asset-based assessment is the energy. So it corresponds to the typical energy performance certificate assessment that actually takes place in all the countries, but the difference here is that it does not intend to actually indicate a specific energy class for the building, rather than compute a building score that will actually be used for the final asset rating EPC assessment later. Now, the first part here, and this may actually follow in many other tools, is a validation error form that is produced when we first enter this page. So this actually serves as a message to the user in order to provide additional information that could not be retrieved from the IFC file that we uploaded. We have seen that IFC files actually do not contain the entire information that we need in order to perform the energy or other assessments, and this is where the actual EPC assessor role comes into, in order to fill the gaps that we get from the automated extraction of the information from the BIM files, from the BIM literacy. So the first thing that the platform could not deduce was the building type, because it was not, of course, included somehow within the IFC. So to this end, we are going to basically add a building type that corresponds to its use. So our building here actually is used as offices. So we are going to add the tertiary characterization as building type. Following, we have some errors here for the thermal systems, which are required to be filled. So we have some efficiency numbers for the distribution system and the thermal system for the actual heat pumps, and also the energy source for the lighting, which for some reason was not included within the IFC file. So let's just put a few random values here. I'm just going to add 0.9 for the assessment here, and of course electricity for the energy source of the building. Well, submitting the information, the tool actually is executed automatically, and we are able to get the energy indicators of the building itself. So we get a very good score, around 87%, and we're also able to view different metrics here related to energy, as well as related to, well, mainly related to energy and to cost as well. So we're able to view the energy figures as final energy, as primary energy, and also comparing the renewable versus non-renewable part of the energy. We are able to view the energy consumption of the building, split it into different energy services as have been defined from the building, and also split it per energy carrier. Here we only have electricity as energy carrier from the building. Now, this was the first part of the assessment, but of course, and called energy, but we also have different indicators coming up that will eventually form the total asset rating of the building. So the next part is the non-energy indicators. So non-energy indicators actually correspond uh, to the non-energy assessment of the building and study various aspects based on the building characteristics. So one of them is the acoustic comfort, the other one is the thermal comfort, visual comfort, the indoor air quality, and also some other aspects that we will see afterwards. So the way to set up every part of these indicators is to basically set up assessment zones within the building. So we can either consider the building to be an entire assessment zone, or we can, for example, split different assessment zones that will eventually be aggregated into a single result for each type of indicator. So the first, regarding the first one, the acoustic comfort, we just add one zone. Let's call it test acoustic zone, for example, and we're able to select the spaces that actually this zone actually includes. So the first part here, let me share here. So the first part is to select the spaces that this zone actually includes. Let's say that it includes the entire building. As we select spaces, you can see that much of the information that we require for this assessment to take place, the area of the facade, the volume, these are calculated automatically. This is because of the BIM literacy and the geometry that is contained within the IFC, which enables us to actually perform this assessment without needing to measure anything or to calculate anything by hand. So it's quite straightforward for this information to be filled right here. We select the destination, so mainly the type of the building for this assessment. We just select offices here. Let me see. So the general offices type. We select the type of the road that lies outside of the building, so it's quite a normal street. We select the noise ratio here, and also the glazing type. So the glazing type is triple glazing with a low factor of noise, because there are relatively new offices here. We enter some information that cannot also be retrieved, like the external wall mass. So it's 150 kilos per square meter here, and other coefficients have been filled automatically as default values. So if we submit and actually perform the calculation, we get the results for the building compliance. We can see that it reaches a very good score regarding the acoustic comfort, almost 92%. And it performs quite well regarding the target for noise and reverberation as well. Now, the next tool that we will continue with is the thermal comfort. So there are a number of parameters that have been pre-filled here. So for easiness, I will just leave them as they are, but they should change in order to reflect the actual parameters of the building. Again, we need to form a thermal comfort zone in order to be able to perform the assessment. We will just call it test thermal zone. Again, we are going to select. Let's now select just one zone, one space at this point, in order to see how this actually changes the assessed area that we have. Let's select 10 occupants that actually occupy this space here, since it's an office, and let's select the occupancy hours of 8 hours, let's say. So if we perform the assessment at this point, we also get a relatively good score of around 82%, with good scores regarding the PMV, the predicted mean vote, and also the predicted percentage of dissatisfied, and the relative humidity as well. Next one in the line is the visual comfort. Again, we should add we should add the zone here. So let's call it test visual zone. Again, we need to select a few we need to select the spaces that we have. Let's select again. Let's perform the assessment, selecting the entire building that is relatable to visual comfort. We select an office here based on the assessment that we want. Here we need to enter a few more details that could not be retrieved from the AFC as well. So again, the glazing type. So we have to include the angle factor for the glazing. So it's 90 degrees. The maintenance factor here for the glazing type as well. So let's say 0.6. Let's say 2200 kelvins for the lighting, and the CRI, the common rendering index, let's also call it around 90%. And the nominal type would select LED lamps, new ones, and around 400 watts of 4,400 watts of actual electric power for our LED lamps. So we basically submit everything here. We can run the calculations, and we get building score again, and also the actual results versus the target ones that actually provide this score here. As you can see, we just study luminar temperature, the luminance, the daylight, and the CRI, the luminant color rendering. Now, the final tool that actually requires a zone setup is the indoor air quality tool. So here we have, again, need to set a, call it test zone. We select a few spaces that will assess the indoor air quality. We will select again the entire building. The activity here is resting, so no one's actually doing some intense work. And we then need to characterize the windows in order to calculate the correct infiltration type from the windows. The windows are new, they're aluminum, they have ceiling gasket as well. And we're able to also add a few information about the building that is required from the assessment itself. So the building is an individual one. It's not a part of a multi-apartment building. It's sheltered class is sheltered, so there are other buildings within. It gets medium exposure from the wind here. Its occupants are around 10 in our case overall, and our CO2 target is 800 ppms, where we need to not avoid this in order to have a favorable indoor air quality within the building. We do not have any mechanical ventilation at this point, and we are able also to select an occupancy profile for the building. This is also quite important because the assessment actually takes into consideration the occupancy of the space. By selecting any occupancy schedule profile, we are actually loading a predefined occupancy schedule for 2 weeks that this assessment requires. And you can see that it's a typical office schedule ranging from 8 in the morning until 6 in the afternoon that this space is occupied. So by submitting and executing everything, we actually get the building compliance and how the CO2 is supposed to progress based on the input that we provided within the building. The final tool of the non-energy is, as we call it, the additional indicators, non-energy indicators. These are we simply need to select a few options from here in order to characterize the building. So characterize its accessibility. We can say that it has good accessibility. The earthquake risk, so it's low to moderate, is a building that is quite new, and its water efficiency, where we can say its efficiency is high. So submitting and calculating, we just get the results for the 3 indicators here. And that was the non-energy tool containing 5 different sets of indicators here. The next one is probably quite known to many. It's the so-called Smart Readiness Assessment, or SRI, of the building. So here we are able to basically perform the SRI assessment according to the guidelines that have been provided in the assessment package. So here we just need to enter the assessment name. Let's put my name and also my organization. To add the building type, let's call the non-residential building. So it uses an office. It's our test building. Let's just put a few information here. So here the important part is the country. So here we just add Greece. I'm able to find it. Okay, here its date is the original one, and its construction year was quite recent, 2021, if I recall. Now we get the actual energy smart domains that each one includes some smart services, and we are able to change the values that have been already been set. The important part here is that we use the IFC file in order to also gain some information that we can for the smart readiness assessment. So you can see that some of the services are already filled. For example, the service, the H1C, control of distribution fluid temperature. But the truth is that the information that can be derived from IFC files is minimal at this point. So the assessor is actually required in order to change all the values according to an actual smart readiness assessment. For now, we'll just leave them as they are in order not to lose time, and completing the whole process, we will eventually get the smart readiness of the building, which of course is quite low since I did not change much from the original extraction. So it's around 10%. The final tool of the asset rating assessment scheme, according to SmartLivingEPC, is the life cycle or LCA assessment. To this end, we are able to retrieve the bill of materials from the IFC file. Bill of materials, of course, is a list, let's say, of the type of the material that we have within the building, its structural group, where it belongs, and also its quantity. This is quite useful in order to perform the environmental impact assessment of the building throughout its life cycle, from its construction up until its demolition. So here's the list of all the materials that is retrieved from the actual BIM file. What is important here is to match these materials to the so-called EPD values, or Energy Performance Declarative values, which is a document that defines what the impact of the material is at each stage of its lifetime when applied to the two buildings. So in order to do that, we need to basically edit its entry here in the materials list, and to either to add the EPD indicators by hand, for example, adding here a few indicators, or for example, to actually search an external database which provides us with the material EPD quite easily. So this is what we're going to do. We're going to search the material into an external database that we address, and we just found one entry in the EnvironTech external database, which is also open source. So if I click here, I will also visit this page where I can see that I found the material that I want here, and of course all the EPD indicators that we need here. So if we just submit this, we get the connection of the actual EPD. The important part here also is that we need to add a few properties to the material itself, because the calculation of that takes place and actually extracts the bill of materials does it in cubic meters, and the actual declared unit of the material that you see here is different, is in kilos. So we basically need to add some information here in order to get this result. The main, let's say, the main thing is to add some properties here. So right now, in order for this to move forward, I will add the default thickness for this material that will eventually convert the required units to the one that we need. So as I saw, the default thickness is 12.5 millimeters. So here we go. We just include this and we are done. So performing the calculation with just one material, of course, but we need to perform this process iteratively for all the materials of the building. We get the LCA results. Of course, we get a very good score here because we just have one material and its impact to the building is probably negligible regarding its environmental impact. So we get the results as impacts per material. We would have more materials here again if we had set them up, and the impact per stage and per structural group as well. Now, consider that we have executed all the tools here. We are able to basically perform the asset rating assessment, which aggregates all the results from different tools here into one specific rating here, the total asset rating, as we call it. The weighting scheme that we use here is a default one, but is supposed to be based on the country, of course, to have specific country standards regarding the weighting, but also to the building type or other parameters. And this is the asset rating of the building. So in order to move forward, we can just go to the operational rating. Now, the operational rating, as I said, actually relies on building data, measurements from the building, from energy meters, in order to perform the assessment based on this data. Again, we are met with a validation error, so we need to add the information here. So the construction year of the building, 2021, and also the use of the building, which is private offices in our case. Performing the assessment, we get all the measurements from the locally stored database, and we get the building score again, and of course the indicators that correspond to these measurements. We're able to see how the different measurements are split between different uses. Remember that this is how we essentially create the devices. So we created two devices, one measuring lighting, electricity appliances, domestic hot water, and one measuring heating and cooling. So this is how we are able to view this information disaggregated. We're able to also view some other energy indicators, mainly as primary energy or final energy, and per area, volume, occupant, etc. And for easiness, we are also able to view the daily primary energy consumption, how it varies within our building, in order to get a good understanding of where the energy consumption actually peaks or is lower, and we can actually take energy efficient measures. The next tool that we have here is the life cycle costing tool. So this tool actually has actually relies on the results of the energy assessment here, and takes into consideration monthly energy prices for its energy carrier of the building. This allows us to get the cost representation of the energy consumption of the building, and to be able to compare the designed costs, so the costs related to energy of the building as designed, and the costs of as operated. So here you can see that we don't have much difference, but what we have actually seen within pilot sites is that we have a huge difference between the designed costs and the actual operated costs of the building, which of course highlights the difference between the asset-based and the operation-based energy assessments in our case. We can also view a short, let's say, representation of a life cycle assessment for our building for the next 10 years we have here. Final tool for the operation rating is the IQ, or indoor environmental quality. So this tool actually is similar to the non-energy tool, but uses real-time data from the building in order to perform the assessment. So the first subgroup of indoor environmental quality indicators is the carbon dioxide one. So we perform a similar assessment. So because essentially we need to create some assessment spaces, and the spaces that we're able to select are only spaces that have devices that measure the specific measurements that are required for the calculation. So if you remember, we added a CO2 sensor in space one. So this is just the one that is available at this point. We again get some information automatically from the IFC file. We just assign an office to the space itself, and also let's say that this place has around 10 occupants. We again are able to select the occupancy profile of the building, or if we just leave it blank, the tool itself will try to find any occupancy sensor that is installed within the building and perform the assessment only in the times where the space is occupied. In our case, we don't have any occupancy sensor, so we just select the office schedule that I showed you earlier. Submitting this and performing the calculation, we get, of course, the results. We get the overall building score, and also other, let's say, the disaggregation of the results, showing how the measurements actually span within its category overall, monthly, and also during its week of the assessment. Here we can also change the time range of the tool, so how many measurements we use to establish the results, and by default we use 6 months for this reason. The second tool is the particle material, but as you can see, we cannot add any space because we don't have a particle material sensor. We have not actually installed one. So we're basically moving to the next tool, which is the virus risk. So here we assess the virus potential within the space. We can select any space at this point. So let's just select space 2. Again, some information is retrieved automatically, but we need to add a few more. So let's add the flow rate for the building. So let me also show here. So let's add a flow rate of around 5 meters per second. Again, let's say that the building has 10 occupants, and we also have 1 infectious person within. The vaccinated percentage in our case is around 80%. And let's leave other information blank as it is. So if we just submit this and start the calculation, we get a score of 100%, so very low virus risk or reproduction rate for the virus inside the space that we assessed. The occupant feedback is the one tool that is does not rely on actual measurements from the building, but relies on questionnaires that should be handled to participants in order to gain an insight from the participants, from the residents, let's say, side, from the occupants of the building about the indoor quality of the space, and this is also taken into consideration. So if we just select one space for the assessment, we need to select a participant group. Let's name it group 1, and we add a few answers here as a result of the questionnaires that are being handled. So let's say that I don't know, maybe here 8 participants find thermal comfort to be okay, and other participants find it to be a little bit cool, the 2 participants here. If we consider that the space has 10 occupants as we entered in the previous assessments. Let's say that the indoor air quality feeling is fresh, and also the draught comfort is slightly draught for 5 people, and let's say no draught for another 5. Submitting this, we just perform a weighted calculation that will eventually yield a building score in terms of occupant feedback. Finally, thermal comfort is the last tool of the indoor environmental quality, and also the last tool of the operational rating. And here we should add another space for the assessment. As I recall, we added a sensor with measurements in space 2, add the metabolic rate as well for the IQ, and also select an occupancy profile. Let's now select the building office. So if we select the 6 months, we are also able to select the season that where the assessment is performed. And at this point, I will just select the infer from time range, because this will automatically decide based on the outdoor temperature if the season that we are looking into based on the data is heating or cooling. So submitting this and running, we get very bad results, because we have at least 80, almost 30% of measurements out of the assessment category. So we have times where the thermal comfort is not favorable. And to this end, we just get a bad result here as well. Executing the total asset rating, and as we have done with all the tools, we are able to view the results per indicator here, and also view the total operational rating here. And this was the presentation for the asset rating and the operational rating for building units. In order to proceed, let's just move on with the complex, and then we are able to fill in also the assessment. So the assessment that we show right here actually corresponds to building units. But the project itself actually researched the assessment of building complexes as well. For us, building complexes are actually composed of building units within the platform that we are able to form exactly as we do with a building unit. Right here, you can see that the complex management page is similar to the BIM management one, but instead it includes building complexes. For example, here you can see the pilot building complex that we have called Leja Building Complex, and it's the one here in Leja, Spain. For easiness, we're going to use this one, but the way to form a building complex actually consists in selecting a building that will act as a basis of our assessment of our complex formation process, and we need to basically draw a building complex around the building as a base. So if we do this, and imagine that we have many buildings here, we're able to select nearby buildings that actually lie within the area of the complex that we just created. And we also get, of course, automatically the area of the building complex itself. Now, consider that we've done this. The complex assessment procedure can continue. So we have set up the Leja building complex that I showed you earlier, and we need to enter a few variables regarding the different aspects of assessment that we do for building complexes. So we have neighborhood, renewable, demand-side management, EV chargers, mobility transport, building inventory, and the poverty and life quality. So the assessor needs to basically enter these values here, but some values can also be filled automatically as a result of the building complex assessment by just clicking autofill here. The same thing goes, of course, with the operational rating, but this time it uses also real-time data from the buildings or complex devices that measure utility, let's say, equipment within the building complex. We can now perform the calculations. These have been set up already, and we get the total score from the building complex and also specific scores for each type of indicator. The same thing goes, of course, with the operational rating, where we get the score and the distinct indicators for building complexes as operated. And I hope this didn't take too long, because I think now it's time for the second part of the survey. So if you're still here, and then to finish off with 2 more sections, short ones, before ending the conversation.
Hi. Hi again. Now is the time to the second questionnaire. In this case, we have 3 sections. First of all, about the SDR integration into Smart Living APC assessment with 3 small questions. The second section is about upgrade to operational APC rating process with other 3 questions. And the last is about the complex question, resident perception of the neighborhood rating scheme with 11 questions. And the last is an open question if you need to extend your comments or make give any information. Okay, thank you very much. We have now time to answer those questions.
So 25, let's move on and try to wrap it up. We're already extending for 10 minutes the intended duration of the webinar. But yeah, I think
Yes.
it's quite interesting, and also it will help us to ensure that everything is recorded, and yeah, it will be made available not only for the participants but also for the wider audience at a later stage. So yeah, Nikos, you can continue.
Thank you, Pablo. So there's not much more to say, just another section, and we'll be able to finish, and also with the last part of the survey. So as we saw, we basically performed the assessment of the building related to its asset state and its operation state. But we have also designed some tools that are supposed to be executed after we performed each assessment, and we want to see how the building that we have assessed actually stands out against other buildings. And this is the energy benchmarking set of tools that we have. So the first, let's say, service that we have developed is called peer comparison. which essentially performs a clustering of buildings within the platform and is able to show results, comparative results of our building in relation to other buildings with similar characteristics. So here we're able to select a number of clustering features or features that will actually determine the data set against which our building is compared with. We have created a synthetic data set in order to be able to view some indicative results here. So let's say we perform the benchmarking using the construction decade. So we essentially compare our building with buildings that have been constructed within the same decade. In a similar manner, we could select buildings with the same primary usage, so offices, buildings within the same European region, within the same country, or with more or less the same area, and so the same size. Or we can select more than one features in order to narrow down the comparison that we have. So here you can see that, for example, we did not find any other buildings assessed within the same constructed within the same decade that have been assessed regarding their asset-based performance, but they have been assessed regarding their operational performance, and we're able to view here a few comparisons for its type of indicators that we did. We are also able to compare our building with a median building within, but also against the top performer that we have here. And we're able to view some improvement, let's say, margins that we might have using these spider graphs here. Additionally, we're able to also look at the best features that our building has in order to pinpoint any aspects of improvement that we could use later in case of a major building renovation or changes to the building in general. The final tool that I would like to demonstrate is the cost analysis and planning, which essentially performs a life cycle cost assessment of the building, targeting specific systems and showing how different systems will impact the overall costs, but also the efficiency of the building in the future. So in order not to lose time, because it requires a lot of information, I had prepared an already filled out form here that is able to run standalone, and we're able to basically calculate the life cycle costing here, which performs an indicative, shows an indicative cost for the next 20 years, as I showed here regarding the building office that we have. And this should be it in short for the last section of the presentation. So guys from those two, please provide the last link so we can wrap this up entirely.
Okay, we have now the last part, small, with two parts. The first about building stock enhancement with 3 questions, and the last is about overall evaluation of the tool, and of course with a last open question if you want to add any comments. Thank you.
All right, with this last feedback round, we will conclude the webinar. We'll stay for a few more minutes in case anyone has any questions or would like to raise any issues. Apologize in advance for the delay. We needed extra 15 minutes. You see that it's quite a comprehensive tool and that it actually tackles one of the long-lasting challenges of building performance assessments, that is merging several dimensions and that is very significant and quite highlighted in the EPBD4 in the latest recast. So we hope that this webinar was insightful and that it shared the knowledge and significant work that the Smart Living EPC project has made to further advance energy performance assessments, including, as I said, not only other dimensions such as indoor environmental quality, smart readiness, sustainability, but also tackling a big challenge, which is not only the asset, but also operational rating. And last but not least, broadening the scope beyond the building unit to also include assessments at the complex level. With that, I think we can conclude the webinar. As I said, we'll remain here for a few more minutes. But yeah, as you progressively complete the last round of survey, we thank you for your participation. And yeah, if you want to know something else, feel free to. I'll paste right now the social media of the project, the website, so you can stay tuned about further progresses in the remaining months of lifetime in the project. I see Leandro with a hand raised, or Itziber, so feel free to jump in.
Of course, the questionnaires are open now, and we maintain during all the day. And thank in advance to all the participants to have some minutes to fulfill the 3 questionnaires. Thank you very much for your contribution.
And just to remind that Pablo, we can send a follow-up email with credentials to the platform. Of course, not this account, the one that I showed in the beginning, in order for you to view the results. And I don't know, maybe answer the questions if we have not done already, or even send us your feedback either through email or through the functionality of the platform that I show here, the report issue page. Thank you.
Yeah, we will be contacting all of you, all of the participants that are attending, with a recording of the webinar and a list of further information like Nikos and Itziber just mentioned. Right, well, thank you very much, not only to our speakers, but also to the attendees. And yeah, we'll see each other around. All right,
Okay.
Goodbye.
See you. Goodbye, everyone.